Now we're doing letter G in 4.7. The angle whose sine is root 3 over 2. Now that's a positive number, so can I go ahead and draw it in quadrant 1? Yep, you can always draw your positives in quadrant 1 because everything's positive in quadrant 1. Where else will I draw this one? Now stop and think. What's rolling through that head of yours? Sine is y over r. Where is y positive?
2.
Quadrant 2. That's where y is positive. Kids, regular coordinate plane, y is positive up here. So I'm going to have an angle in quadrant 1. Let's see, its sine is root 3 over 2. How big is my angle? 60. So one answer actually is 60, right here. That's 60. How big is the other one? 180 minus 60, which is 120. Very good. So there are all your two answers. All right. Oh, no, this is better. Now we've got all right, so the first thing you notice is, shoot, it's not positive. That means we are going to, Jordan, what are you doing?
I'm working with my pencil.
Your pencil?
Yeah.
And one in your hand?
Yeah.
All right, so we got a cosine that's negative. So cosine is x over r. Where is x going to be negative? Quadrant 2? And where else? Because we know we're going to have two answers. Quadrant 3. Everybody good with that? Now, cosine. So negative root 3, 2. This would be 1. How big's my angle? 30. They're both 30. There was Matt. 30 is not an answer, though. This is an answer. How will we find that answer? 180 minus 30, which is 150. And then the other one will be 180 plus 30, which is 210. So your answers are 150 and 210. Oh boy, now we got a toughie. We got a 0. Now, you aren't going to be able to draw a triangle and get 0, because that would mean one of the sides was 0, and that won't work, of course. So if we got a 0, we're going to have to be looking for an angle on our circle. Now, where did I get all those numbers from? I just drew a random circle up there. Where did I get all those numbers? What was I counting on? My radius is 1. So if I'm using a radius of 1, then I can get those points. You gotta have points, kids, because tangent is y over x. You need a y and an x. So I said, okay, I need a y and an x. I'm gonna let my r be 1, and now I've got y's and x's. If you let your r be something else, you're gonna get different y's and x's, which is fine. You'll still get the same answer. Now this is 0 over 1. So that means I have to look around the circle and find a place where if I put y over x, I get 0. right? Y over x. I have to get 0. So y over x, doesn't it happen right there? So one of my answers is that angle, which is what? 0. That's 0 degrees. Or the beginning point right here. That's one place. Now what about here? If I put y over x, do I get 0? No, I get undefined, so not that one. What about here? If I put y over x, do I get 0? Yeah, so there's another answer. What angle is that? 180. What about down here? Well, actually I can stop, because how many answers am I supposed to get? And I got it, so I don't need to go any farther. How did I know I needed to do that one on a circle and not with triangles like all the rest of them? Because it's a 0, yeah. Those zeros are bad news. Oh, look at the next one. There's a 0. So this means I'm going to need my circle again, right? What'd you say? You say something? I use a radius of 1. What sign? Definition? Y over R. So I need to go around the circle and put y over r and get 0. So if I put, this is y, if I put y over r, do I get 0? Yep. If I put y over r, do I get 0? Y over r, do I get 0? I could keep going, but none of them will work, so I'm done.
You have to go to circle and just draw a line.
You can do whatever you want. As long as you're not cheating, you get the right answers. Okay? Now, the next part. These look so hard, but they are actually easier, I think. Look at this. Now, when we get around to taking a test, you're going to have to do this problem twice. You're going to do it once by hand. That is called the exact value. The exact is when we do it by hand. And then you're going to get the decimal value, which you're going to get by typing it in on your calculator. Okay? So first let's talk about how we do this by hand. Let's cover this up for a minute. Can anybody tell me what that says? Find the angle whose tangent is 3/4. This is an angle. This says find the angle whose tangent is 3/4. So I'm going to go ahead and draw that in quadrant 1. And I'm going to give you a break. We're only going to do the quadrant 1 for these big problems because that's all your calculator will do. If the tangent is 3/4, wouldn't the triangle look like that? Now, is that a 30 or a 60 or a 45? No, but I don't care. Because the problem doesn't say find the angle, it says find the sine of the angle. So I need opposite over hypotenuse, so I need to find my hypotenuse. How will I do that? 3 squared plus 4 squared equals r squared. So 9 plus 16, 5. So the answer to the question, again, I've drawn a picture of the angle, but I don't need to know how big it is. I need to know what is its sine. And the sine would be 3/5, wouldn't it? Opposite over hypotenuse. Now, let's get our calculators out. And let's type this in on our calculator. So this is what we're typing in. And the good news is you're going to type exactly what it says. So you're going to type sine. Now the parentheses automatically come in, so you don't need to worry about them. Second tangent. Now another set of parentheses automatically comes in, which is fine. 3 divided by 4. Now you got a couple of sets of parentheses to close. Did you get 0.6? And 0.6 is the decimal for 3/5.
Miss Ward,
Yep.
so if you do the by hand one, you don't have to do the calculator, because if you know the bottom line, you do the top line.
Well, most of the time, I rigged this first one and the next one are rigged, so there's no radicals. Most of the time, you're gonna get radicals in this answer, so you'll have to get the decimal, you'll just type it in and get the decimal equivalent of the radical. Okay? These work out really nice, because I planned them that way. But actually got a couple of nice ones here. So the next one says, find the cosine of the angle whose sine is 5/13. So the first thing we're going to do is draw a picture of the angle whose sine is 5/13. Opposite over hypotenuse. Now, do your Pythagorean Theorem and see if you can come up with the missing side. Remember, it'll be 5 squared plus x squared equals 13 squared. So what are you getting? 12. So now I've drawn a picture of the angle whose sine is 5/13. Now, what do I want to know about it? I want to know his cosine. Well, can you look at the problem and tell me what the cosine is? Adjacent over hypotenuse, 12/13. Now, let's type it in on our calculator. Just type that exactly the way it's written. Did you get 0.9231?
So don't you always just get the same thing if you just plug in whatever you got by the exacts by hand?
Totally, but then you won't know if you have the right answer or not. Because your calculator's not, I mean, that's easy to type in on the calculator.
Yeah.
So if you, then what I would do is, I'd go ahead and type it in on my calculator, and then I'd check to make sure 12/13 is that decimal. You absolutely can, but then if you miss one, you're gonna miss them both. All right.
And that next one, is that extra parentheses, is that just how it shows up in the calculator, is that why it's there?
Yeah, well, because when we have a negative in there, yeah. So now this next one, this is where things get a little bit tricky. So I'm just gonna tell you, this is the only one I put a negative in, and I really didn't think I was gonna put any negatives in. So I'm just gonna tell you where to draw this, because you start here, just like we did before. We have to draw this angle. Now, I won't draw it in quadrant 1. Would you agree with me? Because drawing it in quadrant 1 would mean it was positive. So with the sine, we're gonna draw it in quadrant 4. You don't need to know that. I'll I'll give you that information if I expect you to have it. There are some rules associated with the calculator that we don't need to mess with. So I'm just telling you, draw this in quadrant 4. Can't draw it in quadrant 1. You should realize that. Can't draw it in 1. Could be drawn in 3 or 4. We're going to draw in 4. Now, the sign is -4/5. Right? Because this is my angle right here. So now I'll do my Pythagorean Theorem. It's another rigged problem. What does that missing side turn out to be? 3. Now I want the tangent. The tangent of that angle would be what? -4/3. All right, let's go to our calculator and see if that's what we get. When we do tangent, second sine, -4/5. You get the right answer?
So like when we're recording decimal, do you always want us to like go to the nearest 10,000?
No, the directions say on the test.
Okay.
Usually, problems like this are quite a few decimal places.
Okay.
All right, now we got one with that's going to have a radical in it. Let's see how this works. No different, actually. Just your answer's a little bit uglier. We're going to find the cosine of the angle whose tangent is 2/3. So how do I start? What do I do first? Draw my picture. Where will I draw it? In the first quadrant. +2/3. Bo, you awake, sweetie? You sure? Tangent, 2/3. Right, opposite over adjacent. Okay, can you find the hypotenuse? Square root of 13. Anybody have a question about that? 9 + 4? I have no idea what that angle is, but I don't care. I need its cosine. What's the cosine of that angle? 3/√13, which is 3√13/13. Would everybody agree with that? Let's see if that's what we get when we do it on our calculator. Cosine, second tangent, 2/3. Decimally, I got 0.8321. Like I was telling James, I can check now to see if I got this right. I'm going to type 3 divided by the square root of 13. And guess what happens? Same thing. Which simply means we're right. All right, 2 more of these. Let's see if we can get the hang of it. Here we go, quadrant 1. Now, cover this up till you get your picture drawn. Cosine is √7/4. So √7 squared plus y squared is 4 squared. What's √7 squared? 7. Looks like y is 3. Is that right? And what do I want to know? The sign? What's the sign? 3/4. Let's check it on our calculator because we're going to need a decimal anyway. Sine, second cosine, square root of 7. I I got 0.75, so we are right. How are we doing, okay? Last one. See if you can set it up on your own. See if you can draw a picture of it. Use the Pythagorean Theorem and answer the question. Are you drawing it in quadrant 1?
Yep.
Good. Start inside the parentheses. Draw a picture where the cosine is 3/4. What'd you get for your other side? Have you got it yet? Root 7? So the answer is root 7/3. That is exactly right. Now let's do it on our calculator. See if we get the same thing. I got 0.8819, so I'll do square root of 7 divided by 3. Oh, same thing.
I got a completely different number, so I got like 0.5345.
Okay,
You
when
put-
you
you
hit
didn't
square
close-
root of 7,
you
when you
closed
hit square root,
parentheses.
you gotta close the parentheses before you hit divided by 3. Because you only want the square root of 7. You don't want the square root of 7 divided by 3. So type in square root.
Well, like, I think I typed all of it in right, so I don't know why I'm getting rid of it.
Oh, wait, you typed in, okay, I was thinking you were checking that, you were typing this in from the beginning. Tangent, second cosine, square root of 7. Oh, because this is what we're typing in. We're typing in tangent, second cosine, 3/4. You
So-
typed the answer in. This is the problem, Max. This is what you're typing into your calculator.
Okay, yeah, I did it backwards.
Okay, all right, let's see if we can get one or two of these word problems done. What this means is we are getting close to the end, so we'll probably start reviewing next time. So we'll be definitely looking at a test next week. Definitely. I don't know. So sometime next week. All right, here we go. Number 1, 4.8. Number 1. Draw a picture, write an equation, and solve it. We have done these before. We have a bird in the top of a tree. Here is the tree. There is the bird. Point on the ground 100 feet from the base of the tree. So here is the base of the tree. Here is the point 100 feet away. Find the angle of elevation of the bird. So the bird is looking down at this point. There must be a bug or something down there. He is looking down at that point. The bird is 18 feet above the ground. Our job is to find the angle of elevation. Where is that? Who remembers? We talked about this. Jordan? Where is it, Jordan? It's right here. that is where you are going to put every angle of elevation, every angle of depression, every angle of either one is going to go there. All the time. So now we've drawn the picture. Now we need to write an equation. Now remember, the equation that you write will be a sine, cosine, or tangent, period, depending on the information in the problem. So what do you think you'll use this time? Sine, cosine, or tangent? Why did you choose tangent? You are correct. Because with regard to your angle, you have opposite and adjacent. So the tangent of x equals 18 over 100. Kids, when we talked about this before, I said, remember, when you write down sine, cosine, or tangent, the angle is hooked to it. So sine 58 degrees, tangent x degrees, cosine 19 degrees. The angle is hooked to the function. Oh, how do I type this into my calculator?
You're gonna wanna bring 100 over. Multiply by 100.
When you are looking for an angle, you use your special buttons, just like we did over here. When we were looking for this angle, we had to use that notation. So the answer is second tangent, 18/100.
0.1781.
So somebody got 0.1781, but someone else got 10.2. We're supposed to round to the nearest hundred, so that would be 0.18 or 10.20 degrees. The difference is, this is radians, this is degrees.
So my answer is right?
Did the problem say you had to answer one way or another? No. So we answered either in radians or degrees. Why are we all packing up? It's 8:47. No, it's not time to go, and you are making me mad. So the answer is either 0.18 radians or 10.2 degrees. We're going to do one more problem because you made me really mad.
Let's get it.
Sorry.
What? Where's the mustache?
All right, so here we go. We got a worm on the ground, a bird in the top of the tree. Looks like the same setup.
No.
The bird's angle of depression is 24 degrees. So this is 24 degrees. The tree is 19 feet tall. And what am I finding? Find the distance from a worm to a bird. So where's my X?
On the bottom.
Hypotenuse. Where is the bird? Where is the worm? That is the distance between them. This would be the distance from the worm to the base of the tree. That's not what the question was. All right, I need a function, sine, cosine, or tangent.
Sine 24 equals 19 over x.
Sine 24 equals 19 over x. How did she know that? Opposite and hypotenuse. Now we gotta get x by itself, so we'll bring it over here. We practiced these before, you guys. We'll bring it over here, and then we will divide. Now, this angle, Olivia, is a degree measure. So in order to calculate this, you must be in degrees. You must be in degrees to get this one. So 19 divided by sine 24. What do we get for x? 46.71. Make sure you are set in degrees. Type 19 divided by sine 24, nothing fancy. Everybody getting 46.71? And the unit on that would be? Not degrees, feet. How far is the worm from the bird? That would not be degrees.
46 degrees away.
If you're given a degree angle, yeah. Yep. All right, have a good day.